what I want to do is take a little break from Objective-C and try to explain to you what's going on with respect to the memory when we create a class. Objective-C actually doesn't store the individual or most of the individual objects in the class itself. And you need to kind of understand this just from a memory management standpoint to help understand what's going on. So with iOS 5 that came out, we actually gained the ability to have the operating system handle, or the programming language handle, our freeing of our memory, so that we're not having to go in and do reference counting. So I want to kind of explain to you what it's doing for no other reason than just to help you understand. So let's say that we have a class that we set up, and we'll just call it class 1. And we've got a couple instance variables. So let's say that we come in and we create, let's say, an NS string, and we call it S1. And then we got another NS string, S2. And then we'll have an integer, which is a native type C style variable, and we'll just call it I. And then we'll do our end of class. So we've got some instance variables that we've declared here. So let's just, for the sake of argument, say that a string is 20 bytes. And let's say this is 20 bytes, and let's say an integer is 4 bytes. Well, what ends up happening inside of Objective-C is when you create an instance of this class, let's say we have C1, which is an instance of that class, the class itself does not actually hold these variables. So when we create this instance of our class, what we end up with are pointers. So we'll just say PTR. So the class ends up having, let's say that this area of memory is the actual class. And let's say that this area of memory up here is our S1. And then somewhere else out in memory we have S2. So what happens is inside of our class we end up with S1, but it is actually a pointer to the address of, so this is a pointer. So S1 points to an area of memory that is holding that particular variable. And if you watch the other videos on pointers, you'll understand that this is not actually the variable itself. It's like a tag or an address. Think of it as a sticky note that tells me the address to this home of this text that we're looking for. By the same token, we'll have S2, and it is a pointer that points out here. Now, pointer, let's just for argument's sake say a pointer takes up 8 bytes, which means that our class, when we create an instance of the class, it is a lot smaller than you would think, because instead of holding these bigger, longer strings, it's only holding these smaller addresses to where those strings reside. Now, this does not mean that we're saving memory. These variables are still, they have to exist somewhere in memory. So we still have the memory location. It's just the instance of the class that you're dealing with isn't having to pass that around or deal with it. It just, whenever it needs to get to S1, it goes and looks up the address to S1, goes out on the heap and finds S1. Now that brings up a whole nother question. There's a concept of heap and there's a concept of stack, and you'll hear these with respect to memory and what they actually are doing and what they mean. So I'll try to explain that real quick. So let's think of heap is the address space that all of your variables, your classes, and all of that kind of stuff are stored. So think about it's a heap of just memory. It's just this big glob of memory, and whatever it is that we happen to be needing to store in that memory, it goes out and looks in the heap and finds an empty spot to put it and then sticks it in there. So the heap is where all of our variables and classes and objects and all that kind of stuff are stored. Now, the stack is a completely different thing. The stack you can think of as a stack of functions. So let's say that we have this big stack of memory, and it literally is a stack. And so what happens is, let's say that when this program runs, it calls a function called main. Well, what happens is the system comes in and it sticks main in the stack. Then main turns around and calls function 1. So we have function 1. And so what happens is the system then comes in and it moves these things. It actually works from top to bottom, I think. But so what it ends up doing is at first main starts up here. And then when we call function 1, main gets bumped down 1. So we'll ignore these things. Let me just erase this because this is not really, I wanted it to point to the top. Let's see what happened here. So what we'll do is we will switch these around and we'll make, so at first main comes up here and it gets on our stack. Then when main calls function 1, main actually moves down 1, and then this comes up here. And then let's say that this function calls function 2, and so now main moves down again, and this thing moves up here, and then the new function 2 comes up here. So what ends up happening in that case is we would have main, and then here we have function 1, and then we got function 2. Well, as soon as function 2 gets through running, function 2 is popped off of the stack, and now they start to percolate back up again until eventually main becomes the function that we have up here at the top. The other two functions are gone, and then eventually main actually exits out and we're done running the program. So the stack is nothing more than a list of pointers to all of the functions that we have executed. So you can kind of think of it as a way for the computer to keep track of the hierarchy of functions that are being executed. And if you think about a typical application, it could get really complicated trying to keep up with where all this stuff is stored and what, you know, hey, I just got called from here. What do I need to do when I get through running and I'm exiting? So the stack is just a way for the computer to keep track of all of that. So the heap and stack are fairly simple concepts. So just remember the heap is where all your variables are getting stored, and the stack is where the function pointers and stuff are. Now, back to what we were discussing, the point that I'm trying to make here is, and we didn't really get into the integers, the integer is actually not an object. The int variable type is actually a C variable type. So it is actually stored in the class itself. So wherever the class is stored, the integer value is actually stored over here. So only the objects that you create inside of your class are getting stored out here on the heap outside of the class itself. Now, this could, depending on what you're doing, you might be able to get some advantage of this and have multiple classes using the same variables out here on the heap. Most of what you'll be writing probably isn't going to really care about the fact that these things are stored outside of the class. But if you ever go and ask a class, an object, an instance of a class, how big it is, you need to keep in mind that it is not including all of the outside things that it's referencing because of the fact that they're objects. Because inside of Objective-C, you can't have nested, like you can't have one object that literally holds another object. All the objects have to be out here on the heap as their own thing. and that's the way that it keeps track of it. Now, the other thing I wanted to mention here before we quit is reference counting. In older versions of iOS, you actually had to keep up with the fact that you created this object and you had what was called a reference count to this particular object to tell the system that, hey, I own this particular object and I do not want you to clean this thing up. I don't want you to do anything to it because I'm using it. Well, then as soon as this class exits, as soon as you close or kill that class, it would then go in and say, okay, well, now I need to dereference this particular variable so that the system knew that it could go and clean that thing up and restore the memory for other programs to use. Because if you keep in mind the iPhone that's sitting out here is a fairly small device, and it doesn't have a whole lot of memory. It doesn't have a whole lot of heap. So as every single program is running, they're all using this heap to go out and create little pieces of memory to keep track of whatever it is that they're trying to store. So when one function gets through and it doesn't need that particular area of memory, then we need to be able to let the thing go in and clean out these particular areas so that it can reclaim that memory area and use it for other applications. And iOS will actually shut down your application if you don't operate in a nice, clean way. So you want to make sure that you're paying attention to this stuff and keeping all this stuff oriented. Now, with iOS 5, it no longer is necessary for us to have to manually go in here and increment and decrement these heap counts or these reference counters. The system will actually do that for us now. The only thing about that, though, is that when we create these variables and we do different things, and in upcoming videos we'll get in a little bit more of this, but when we go in and create our other objects, we need to tell the system whether or not we want to keep that item around or whether, you know, it's okay to clean it up whenever it wants. So there's still a little bit of manual intervention at some point. Now, most of the time, the operating system is going to be able to clean it up on its own. So it's nowhere close to being as cumbersome as it used to be with iOS 4 and earlier. So in the upcoming videos, we'll actually be using some of this and showing you know, exactly what it means to do these variables and objects and stuff, and the best way to actually create them in your classes so that they're freed up as soon as they possibly can be.